What's up guys, Richard here, welcome back to my channel. So what we're going to do today is this. I've made a really crappy model of a turtle in Blender, but I've applied procedural animation. That means there is no animation models, it's all just done mathematically, which allows me to do stuff like this. It looks like he's kind of walking. Now this could be improved like a billion-fold. Procedural animation, you could make an entire character move based on just mathematics, like where he is, what he's doing, stuff like that. There's so many things you could do, but I'm going to teach you how to do this. Now, I'm not going to step through the entire code and basically type out the thing for you because it's the same process times 4 for each one of the flippers. And when I started to do that and walk through the process, the video turned out to be over like 50 minutes and I was like, this is just tiring and it can be buggy. So I'm just going to walk through the process and explain what my code does. You can pause the video, look at my current code and make changes as you want. Now, I will include the model in the description of this video. You can download it and try and implement it yourself and see how it goes. So what you want to do is have a model that's rigged. And you want to find out the names of the bones located at the ends of the flippers in my case. To find that out, it's not easy. When you drag the model straight into Flax here, you can turn on bones and you can see skeletons over here, but you don't know which bones are which. You can kind of guess it based on like the hierarchy here, but if you really want to know, drag a model into Blender and then just move bones around and go, that one doesn't move it, and that's the one I want, so I want to move this bone, which will pull on this bone to move the flipper. So this bone is called def side fin L001_N, and this one's called def chest fin bot L_N. So that's basically how you can do it. Now, this is a terrible model, it's got way too many bones, it doesn't need them, but it's just for demonstration purposes. So the way you tap into the bone system, there's several parts to this. First, you need to drag your model in here. This is just the skin model, so I've literally just grabbed him and dragged him in, okay? And then you've got to add to him, if you go under other, you've got bone sockets. You need 4 bone sockets. So I've got front left, front right, back left, back right. And for each bone socket, if I select the front left, you'll notice down on the right hand side under bone socket, it says def side fin L001_N. It's the same for the right, but it's an R. And then for the back, you've got the def chest fin. That's referencing those bones I was just talking about in Blender. So you just set those up, and when they're correct, they will appear roughly in the correct position on the turtle. So that's how you know that you've got the right ones. Be careful though, because sometimes there's other bones involved, like these org ones, which I found weren't the bones, but they will snap into the correct position, but nothing will happen. Okay, once you've done that, you want to create an animation graph. So here, you'll notice my turtle's collapsed in on himself. What I've done is I've created 4 vector 3s for each one of those bones, front left, front right, back left, back right. And then I've added these nodes, these 2 bone IKs. And what this does is inverse kinematics. So it basically grabs the bottom bone and, then moves it and affects the bones above it, or at least affects 2 bones above it, or 1 bone, I can't remember exactly, but it affects the bone above it. And when it does that, it allows you to have things like this, where you hold the position of the leg in 3D space, and when you move the body, that leg just stays in the same spot if the vector tells it to move there. But then you can then teleport it over there, which means that bone will move, and you can create like a walk cycle. So all you got to do is have 4 of these dragged in, and then for the target position, you go the front left goes to one, the front right to another, back left, back right. So they all go into a target, and then you need to specify which bone they're targeting, and you just do that whole process of selecting. Unfortunately, Flax doesn't have a search mechanism, so you've got to manually do this at the moment. For my model, you don't need to worry about joint target, but joint target basically says which way should the bones bend to reach the destination vector that you've selected. Because sometimes they'll collapse in on themselves, and then if you're trying to walk forward, your knee joint's going to fly like backwards and be like, and you're going to be like, oh, and that's what the target is. It's basically to tell this in local space which way the bone should bend to reach this target, front, left, goal, or whatever. Now, because these are all set to 0, you can see the turtle's literally collapsed in on himself, because 0 in local space is the middle of the turtle. Okay, so you've set up that. That's pretty easy. You can literally just copy what I've got here. I'm not going to make changes to that. Then you need a script for the turtle. Now, if I select the turtle, you'll see I've got this script called turtle. Not the most exciting name in the world, but I'm going to walk through this script. I am not going to type this out. It will take me an hour to type it out. Not because it's complex, but because there's repetition for each one of the flippers. And it's actually pretty hard to like abstract that out and put it into separate classes. But let's have a look. So front left start position. So this is the start position of the flipper before any movement. Now, I'm going to open up Paint and I'm going to draw out my turtle because we're going to need to draw this out for you guys to understand. So here's my turtle. He's got his flipper, 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 and flipper, okay? Now, at the end of each one of these flippers is these start positions. So, and start. So, I'm going to grab that and I'm going to copy in. I'm only going to reference the front left for all of my code, just so you can see how it works. So this is the front left start position. And then that would be and this one over here would be the front right, obviously, and then the back left, etc. Okay, so now I'll go back into the code. That's the start position. This is the position I want to move the flipper to if there has been enough change in movement. So this is basically a projected position. So if I go over to here, I'm going to then have the turtle's flipper in the future go somewhere like over here, okay? And then that is this projected position. This is where I want to be at the end. So it's got to move between here to here. Now, the next one is the front left bone, or the bones. References to the bone sockets. So these are in reference to each one of these. Okay, simple enough. And then this is references to the animation vector 3s. So that is in reference to, you probably guessed it by now, the animation graph, these. Now, first, let's just delete this. This assigns the bone sockets. So this is basically just accessing the actor and finding the bone that's called front left and assigning it to the front left bone. So that would be this one right here, front left bone, okay? And you do that for each one of them. Now, down here, I'm just going to jump down. This one assigns the references to the vector 3 in anim graph. So this basically goes, accesses the actor, and then you notice up here I've got like this structure as, and then I've got down here, this is just another way of doing as. So it's basically saying access the actor as an animated model, then get the parameter that's called front left. So if I come here, you'll notice this is front left. So that's assigning those. Now, at the very beginning of the game, I'm saying, hey, at the start, set the initial position of the start to the bone. So I'm basically saying, just set this right here to whatever the bone is at the start. And then what I'm doing is I'm going, the new target position, this should be the same as the start because the turtle hasn't moved. So basically I'm saying this blue one over here, it should not be over here right now. At the very start of the game, it should be on top. So the target position and the current position should be the same at the start of the actual game. And then I'm going to jump past this little part here, and I'm going to go front left start position. Okay, well this is now going to be projected onto the ground. So the turtles, if you have a look in here, I'm going to close this off. Notice the turtle's flipper is not on the ground, okay? So if I print screen that and go paste over here, what I want to do is simply project this flipper's start position, which is right here at the moment, right here, onto the ground here. So I literally want the flipper from the start to start on the ground. And if I press play, you'll notice that straight away. Boom, see how it goes down towards the ground? That's what that function there is doing, this get ground position. And if I jump down to this function, this is it right here. All it's doing is taking in the position, which at the start of the game is just the position of the bone, and then it's going perform a ray cast from that position downwards. That's what that whole downward arrow was. Perform from this position downwards, the vector 3 down. And then whatever you hit, the hit point, return that. That's going to be the position. If you don't find anything below, let's say he's flying over in space, just return a 0, 0, 0, which is going to make the flipper collapse in on itself. So obviously you never want that to happen. Okay, that initializes pretty much everything that you need, and I've got a few debug statements in here which you can uncomment to test stuff. So in fact, if I uncomment this, let me just uncomment all of this for you guys so you can just see. If I save that, we go save it, and come on, compile, 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 and see how it's projecting these positions onto the ground straight from the beginning. Now that was actually projecting the start position onto the ground. Cool. Now, if I go down to here on the update, this is where the beat of everything's going to happen. So this whole part here, what I'm doing is I'm saying, okay, that target front left position. So you know this, I'm going to have now another situation. So what we're going to do is we're going to have turtle, turtle, and turtle. Okay, so we have at the beginning the turtle's flipper here. But when we move him, this whole, if I suddenly, this is where it is stuck to the ground. It's like sticky rice. It's just stuck there. But as I push that turtle forward, this whole start sticky position is actually going to end up down here. And the flipper is going to be here, okay? And if I kept pushing him forward, eventually it would be down here and his flipper would be like this, which is just totally berserk. You don't want that. What you want to do is when it reaches a certain distance, you then want it to go zoom up to here, like this. And that creates that whole walk cycle type thing. Now, to do that, you need to be constantly projecting, finding out what that future distance is, finding that future position. And when the distance between the two gets too excessively big, then you update this start position to be this end position. But you don't want to do it straight away, because if you do it straight away, it's going to snap. And that looks terrible. What you want to do then is perform a smooth movement to here. So to perform that smooth movement, it means we need to track 3 variables. We've got our front start position, our new end position, and then one that tracks in between, basically. So I hope you guys understood that. What we're going to do is create that tracking. So this is the target position in the future that we might want to move to. Now you'll notice here it's got a transform left, transform right, transform left, transform right, and then these this one represents forward and this one represents, these back ones represent the forward movement and this one represents the side movement. To better understand this, let's again delete this, create our little turtle, go here. Now, if we want to project that position to here, well, we have to first get the position of the actor and offset to the left a little bit and then offset to the front a little bit. So no matter when that actor rotates in any type of way, can I even do a rotation in Paint? No, I can't. So when that rotates in some way, that will always project it to a certain point there when your actual flipper might be down here. And that's how we calculate this projection position. So that's the get projected position. So go to the left by 100 points and then go forward by 70 points. That's for the front left. Now the back left is go to the left by 100 points and then go backwards by 90 points to get like a backwards flipper position. So let's go have a look at this get projected position. Now what this takes in is obviously that offset, how much to offset to the left and how much to offset to the front. All it's doing is get the actor position, get a left offset and times it by that amount, plus the forward and times it by that amount. And then that is going to be floating somewhere again in the air. So then we need to raycast it down, get the ground position. So that will then feed that into there and then return that whole target position. And then finally, we'll have all our projected positions. Now, once we have our projected positions, we need to check if the distance between the projected position and the current position is great enough. So is the distance between here and here big enough? If it's big enough, then perform the movement of the flipper. So that's what this whole thing here does. Check if the projected position is far enough in front. So I've just selected 25 units. If it is far enough in front, update the new front left start position. So this is the new, not the front left start position, the new front left start position to be this projected position. Then what it does is we basically, I don't know why I put absolutes in there. You don't need that. You can just delete that. Just forget about that whole absolute thing. So anyway, what we're going to do is we're going to go, okay, is the new front start position and this one different to each other? So is the new position different to the start position? As soon as you do that projection and it says the distance is, and then you update the new target position, it's going to go, yes, it is different. And then it's going to perform alert between the two. It's going to go da, 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 da. And then once it's smaller, once it's smaller than this 0.3, it's going to stop lerping. That way we don't do unnecessary mathematic formulas, cycles. So then we're going to go the front start position is equal to alert between the front start and that new position by delta times 20. You can put whatever you want in there. That basically how fast the animation will perform that lerping. And then finally, feed the front left start or whatever position into the anim graph. So we're going to access that front left anim position, which we set up here, the front left one, and we're going to set its value to that front left start position. But that front left start position is in world space. We need that in local model space. So that's why we're doing a transform world to local. And that will just feed that in a local space into the animation graph, and the animation graph will perform the manipulation in here based on that 2-bone IK node. And that, my friends, is how you get your moving turtle. If I select him. Yay! As you can see, there's ways to optimize this. This is not the most beautiful thing in the world. You could use a merge between different animations rather than performing just a pure bone IK move. You can stagger the output of the flippers, but I basically just don't have time to do all that. But I wanted to show you what I have done because next week I most likely will not be able to work on this. And I figured maybe this would be useful to some of you guys out there. I hope you understood it. If you don't, ask in the comments and I'll try and clarify. That's it. If you like this video, like it, share it around, sub to the channel. See you all in the next video.